You think you understand existence? Fine. Something is here, so it must be normal. But why? Why isn't there nothing instead? What would nothing even mean? No space, no time, no laws. And if nothing is possible, what stopped it from being the case forever? Most people don't ask. They answer with a word, the Big Bang. But that's not an answer. That's a label you place on a mystery and pretend it's a solution. When you really ask why anything exists at all, you don't get comfort. You get a pressure test on every mental model you use to picture reality. Let me show you. Start with something simple. Look around the room you're in. Pick a corner, a patch of empty air. Now imagine you could delete everything in that corner. The air, the dust, the light, the heat. People imagine a clean, featureless blank underneath it all. A perfect nothing, a default state. But physics doesn't hand you a default like that. Even after you remove every object you can name, you still haven't removed the stage, and you still haven't removed the rules. So here's the first crack. Your word nothing is doing too much work, and you can feel that mismatch in your hands. Hold your palm in that empty corner for 10 seconds. Nothing touches you, but you are being hit by something like a blizzard. Air molecules at sea level, there are roughly 19 molecules in every cubic centimeter of air. They're moving hundreds of meters per second, slamming into your skin and bouncing off. You don't feel individual impacts because they average out into what you call pressure, about 100,000 newtons per square meter pressing on you all the time. And if you take a syringe, cover the tip, and pull the plunger, you can feel how hard the universe resists emptiness. That resistance isn't mystery. It's the kinetic energy of molecules refusing to vanish. And notice what that means. To create nothing, you have to do work. You can feel it with a cheap experiment. Take a suction cup and press it onto a smooth tile. Then try to pull it off. What's holding it there? Not glue, not magnetism. It's pressure. You lowered the pressure inside the cup. The air outside is still pushing with about 100,000 newtons per square meter. So the world presses the cup into the tile, and the deeper you try to pump the air out, the harder it gets. At first, you remove a lot of molecules quickly, then fewer, because emptiness is not a natural resting place. It's a manufactured condition you have to keep enforcing. This is the first mini reframe. Nothing is not the default state, it's a high effort state. Even our best laboratory vacuums are not zero. They're a thin leftover of gas plus a background of radiation plus fields sitting in their ground state. You don't arrive at that by deleting, you arrive at it by building a machine that fights the baseline. So when someone says, why isn't nothing the natural state? Remember, even locally in a room, nothing doesn't just happen. You have to carve it out. So even empty air is not empty. It's invisible structure. And your senses mistake invisibility for absence. Every time, and that's the problem with the word nothing. Everyday language uses it for nothing, I notice. But physics uses it for a state with specific contents and constraints. So let's slow down. Let's stop borrowing intuition from everyday life and applying it to the foundation of reality. Because once you do that, you discover something that has no easy escape. Nothing is not a simple state. It's a target that keeps evaporating the closer you aim. Now here's the key. Before you ask why there is something, you have to define what nothing would be. Not poetically. Operationally, there are levels. Everyday nothing, no objects you care about, an empty cup, a quiet room, a clear sky. Then there's physical nothing, a vacuum, no particles, no gas, no light. And then there's the hardest version, philosophical nothing, no space, no time, no fields, no laws, no possibilities, not even a place where nothing happens. That third one is what your question really points at. And it's also the one you can't touch without breaking the tools you're using to ask. Because even the sentence, "there is nothing," smuggles in structure. There, a location, is a rule. So we will do what physics always does when language gets slippery. We will step down one level to something measurable, then climb back up with evidence. We start with the vacuum, the closest thing to nothing we can build in a lab, not because it's the final target, because it's where reality begins to push back in a way you can measure. Now, if your intuition were right, if nothing is the natural baseline, then the vacuum should be inert, a perfect blank. But it isn't. Here's the strange part. Take two uncharged metal plates. Put them very close together in a high-quality vacuum. If the vacuum were truly nothing, nothing should happen, but the plates attract a tiny force. Small, yes, but predicted and measured. What matters is not the engineering detail. What matters is the message. Empty space behaves like a physical medium with constraints. The vacuum has structure. In modern physics, particles are not little beads floating in emptiness. They're excitations of fields. And the vacuum is not no fields. It's the lowest energy state of those fields. Quiet is not nothing. Quiet is a specific configuration. So if you try to explain existence by saying something came from vacuum fluctuations, you're already starting from a world with Field's laws and a concept of stability. That is not philosophical nothing. That is a highly structured something. But wait, does that mean we've solved it anyway? If the vacuum can produce particles, doesn't that show something can come from nothing? No. It shows something can come from a particular kind of baseline, a baseline with rules. It answers a different question. How can one form of something become another form of something? Our question is harsher. Why is there any baseline at all? Why is there a rule book that even defines what a baseline means? This is where people try to escape upward with slogans. Maybe the laws just are. Maybe reality is mathematics. Maybe everything that can exist does exist. Those are not nonsense, but notice what they are. They're not mechanisms inside the universe. They're statements about the framework itself. So we need another rung, a rung almost nobody climbs because it's uncomfortable. Reality doesn't reward the model you prefer. It rewards the model that matches what you can measure. Every time when you look out at the cosmos, you see stars, gas, light, you see what shows up, and it's tempting to treat that as the universe. Then reality does something rude. It reveals that what shows up is a minority. Today, our best measurements say that ordinary matter, the atoms that make planets, oceans, bodies, books, is only about 5% of the universe's energy budget. Roughly a quarter is something we call dark matter, and about 2/3 is something we call dark energy. You don't need the exact percentages to feel the point. The universe is mostly made of something that does not show up to your eyes. So if you build a model by assuming that what you see is what there is, you will be confidently wrong, not slightly wrong, structurally wrong. And that mostly unseen point deserves one more concrete anchor, because it's not poetic, it's measured. When we map the cosmic microwave background, the faint afterglow of the early universe, we don't just see that it exists. We see that it's almost the same temperature in every direction. Almost. The variations are tiny, about 1 part in 100,000, a smoothness at the level of 0.001%. So the early universe was astonishingly uniform, but not perfectly uniform. Those tiny ripples later grew into galaxies and clusters. We can measure the pattern. We can compare it to models. This is one of the cleanest examples of the universe leaves fingerprints. Now here's why that matters for the existence question. A universe with wildly different initial conditions would not look like this. it wouldn't produce the same large-scale structure. It might not produce stable chemistry. It might not produce long-lived stars. So existence is not just there is stuff. Existence, at least in a form that supports complexity, seems to sit inside a narrow corridor of conditions. But wait, are we sliding into the idea that the universe is fine-tuned? Not so fast. The word fine-tuned is another label that pretends to be an explanation. Sometimes a narrow corridor is telling you the universe was selected. Sometimes it's telling you your model is missing a mechanism that makes the corridor inevitable. The uniformity itself creates a famous tension. If you run the clock backward in the simplest expanding universe picture, parts of the early sky that we can see today would have been too far apart to have exchanged information. No time to equilibrate. And yet they match to astonishing precision. So you add a mechanism, a period of extremely rapid early expansion that stretches a tiny, once connected region to cosmic size. This is one of the reasons inflation exists as an idea. Notice what's happening. Every time you try to treat the universe as a simple story start, then expand, then form galaxies, the data forces structure into your narrative, extra ingredients, extra rules, extra fields. And whether inflation is exactly right or not, the lesson survives. The universe's beginning is not a bare, empty starting point. It is already a structured boundary condition. Now add one more brutal number. When we count matter and antimatter in the equations, the early universe should have produced them in nearly equal amounts. If they were exactly equal, they would annihilate into radiation and leave almost no matter behind. No atoms, no chemistry, no you. But the universe contains matter, which means somehow in the early history, there was a tiny excess of matter over antimatter, a sliver, in rough terms, on the order of one extra matter particle per billion photons in the cosmic bath. A microscopic imbalance with cosmic consequences. That's not mysticism, that's accounting. There is matter left over. So existence is built on asymmetries and initial conditions that are not explained by Big Bang as a label. They are additional questions. They force you to ask not only why is there something, but why this particular history rather than another? And that loops us back to our ladder, because now you can see the substitution trap again. You ask why anything exists. Your mind hears, tell me the origin story. So it hands you a beginning label and stops. But beginnings are not enough. A beginning is a boundary with properties, and those properties carry information, uniformity, ripples, asymmetry, a low entropy starting point that makes an arrow of time possible. You don't get to say it began and be done. You have to ask, why did it begin in a way that supports a universe with stable regularities at all? Now here's the key bridge. If the earliest state already has structure, then nothing is not the obvious alternative. The alternative is another kind of structure, another boundary condition, another framework. Which means even at the edge of cosmology, you keep finding the same pattern. The universe doesn't let you point to blankness. It keeps handing you constraints. Now bring that thought back to vacuum. When you say nothing, you're often saying nothing I can detect. But the vacuum keeps reminding you that detection is not ontology. The world can contain structure that doesn't show up until you ask the right question. So what does that imply? It implies that the question, why isn't there nothing, can't be answered until you clarify what would count as nothing in a universe where unseen structure is normal. Now, let's go deeper, because even if you accept that the vacuum is structured, you might still try one more escape. You might say, fine, there are fields, but maybe the fields could have been absent. Maybe nothing is still the default. We just got unlucky. That sounds plausible until you ask the next question. Why is the vacuum stable? Why is it a lowest energy state at all? Why is there a concept of energy that orders states from higher to lower? Why is there a law-like structure that makes state meaningful? At this point, people often reach for another word, physics, as if physics is a thing that exists outside the universe and imposes itself on it. But physics is our name for the regularities we find. The question is why there are regularities to find. So let's make the pressure real with a number. In quantum field theory, the vacuum is not empty, and it carries a baseline energy. If you take that idea and naively estimate how large that vacuum energy should be, you get an answer that clashes with astronomical observation by an absurd amount, often described as on the order of 10, 120, depending on assumptions. That is not a small, unresolved detail. That is a sign that our concepts of vacuum, energy, and gravity are not fully reconciled, which means even our best physical, almost nothing, is still conceptually unstable at the deepest level. So the universe came from the vacuum is not a final answer. It's a move inside an unfinished theory. Now the question sharpens. Why does a lawful framework exist at all incapable of supporting fields, vacua, and consistent evolution? At this point, your mind tries a substitution. Watch it happen. If I ask you, why does anything exist? That is a brutal question. It demands a foundation. So the system quietly swaps it for a softer question. What story about beginnings feels familiar? And you answer that. Big Bang, quantum fluctuation, universe from nothing. Notice the swap. You answered, what explanation do I recognize? Not what is actually being explained. You answered, do I have a label? Not do I have an origin, because explanation is not origin. A story can compress facts. A model can predict observations. But none of that automatically answers why the framework exists. So let's bring this together with the thing people say first, the Big Bang. We have strong evidence that the universe was once hotter and denser. We see a faint microwave glow across the sky, a relic of an early time. We see that galaxies are receding in a way consistent with expansion. We see light element abundances that match a hot early phase. These are real constraints. They tell you something important. The universe has a history that can be reconstructed. But notice what they do not directly tell you. They do not say there was ever a literal nothing. They do not say once there were no laws, no space-time, no possibilities. They say there was an early state we can describe, a very different state from now, hotter, denser, more uniform. So the Big Bang is not a single explosive event in pre-existing emptiness. It's a description of how the universe has been evolving from a dense early condition. Now comes the trap. If time itself is part of the system, then before may not mean what your intuition thinks it means. If space-time has an origin or a boundary, you cannot automatically extend everyday causality behind it. Asking what caused the beginning can be like asking what's north of the North Pole. You can say the words, but you might be demanding a direction that doesn't exist. But wait, does that mean causality breaks? Does it mean anything can happen? No. It means you may be applying the wrong handle. Causality is a rule inside a temporal framework. If the framework is what you're trying to explain, you can't assume the rule works outside it in the usual way. So now we've earned a hard view. We can say several things without pretending to have final answers. 1, everyday nothing is not relevant. 2, physical nothing is not nothing, it's structured. 3, the universe is mostly made of things that don't show up directly, so naive pictures are unreliable. 4, our theories about vacuum and gravity collide in a way that signals unfinished understanding. And 5, even the beginning may not accept the kind of causal story your intuition wants to tell. Now we're ready to state the reframe. Existence isn't just having stuff. It's the structure of consistency constraints that make stable histories possible. Or in the channel's language, existence isn't just existence, it's the structure of possibility itself. And that shift changes what nothing can mean. Because philosophical nothing would have to be the absence of that structure. No possibilities, no constraints, no framework. But here's the strange consequence. If there is no framework of possibilities, then nothing is not a state among states. It isn't an option the universe can choose. Choose already assumes time and alternatives. Option already assumes a space of possibilities. So the hardest version of nothing may not be a physical candidate. It may be an idea that deletes the very stage on which candidacy is defined. Now, let's test this reframe against reality with pressure applied, not just abstract. First applied proof, cosmic accounting. If you build cosmological models using only what shows up atoms and light, you fail. Galaxies rotate too fast for the gravity of visible matter alone. Clusters of galaxies bend light more than visible matter can explain. The cosmic web forms the way it does only if there is additional gravitating stuff. So you add dark matter. That's not a story you tell for beauty. It's a patch demanded by multiple independent observations. Let me make the reality punishes the wrong model point sharper. Take gravitational lensing. Light from a distant galaxy passes through a cluster and the cluster bends it. You map the distortion and infer how much mass is present. If you only count visible stars and gas, the lensing says not enough. The bending is too strong. So either gravity works differently on those scales, or there is additional invisible mass. That conclusion isn't aesthetic. It's geometry plus data. Reality punishes what you see is what there is, predictably, repeatedly, across independent measurement methods. Second applied proof, vacuum and devices. You don't have to talk about the universe as a whole. You can talk about systems engineered on Earth. An atom in an excited state does not just sit there forever waiting for a nudge. It can emit a photon and drop to a lower state even in a vacuum. That spontaneous emission is not caused by a nearby object. It is tied to the fact that the electromagnetic field has a ground state with fluctuations and allowed modes. Change the environment, put the atom in a cavity, alter the available modes, and you can change emission rates. In other words, what looks like nothing around the atom is part of the mechanism that determines what happens. The vacuum is participating. But wait, doesn't that again mean something comes from nothing? No, it means the vacuum is not nothing. It means the baseline has structure that can do work in the causal chain. And that brings us back to the root. Every time you try to use nothing as a physical starting point, physics hands you structure, fields, modes, constraints, symmetries, a lowest energy state, a notion of stability. So the question retreats again, like a shoreline that moves as you walk toward it. Why is there a structured baseline at all? Now, some people try a different escape. They say, maybe the universe is a brute fact, no explanation. It just is. That is logically possible. But notice what it costs. It means the deepest question has no further reduction. It means the ladder ends in a wall. Others try the opposite. They say, maybe the structure is necessary. Maybe nothing is impossible. Maybe consistency demands existence in the same way that the rules of logic demand, that contradictions cannot be true. That is also logically possible. But notice what it costs. It means the ultimate explanation is not a physical mechanism, but a meta-constraint, a statement about what must be true for any reality to be describable. And we can't settle which of these is true with a slogan. So where does understanding break down? Exactly here, at the boundary between physical explanations inside the universe and explanations about why there is a universe-like framework at all. You can feel the boundary by trying a simple move. Try to imagine nothing, not empty space, not a dark void, not an infinite black room. None of that counts. Those are spaces. Imagine the absence of space, the absence of time, the absence of laws. The moment you try, your mind reaches for imagery. A blank screen, a dark canvas, a silent stage. But those are still stages. So the question is not merely hard, it's adversarial to your imagination. It attacks the tool you use to picture it. That's why people flee to labels, because labels make it feel like you held it. But that's not an answer. Now here's another way to see the same trap. Suppose you insist that nothing is possible. Then you have to explain why it isn't actual. And any explanation you give will invoke a rule, a principle, a law, a probability, a tendency, a selection effect. But the moment you invoke a rule, you've left philosophical nothing. You've rebuilt structure, you've admitted a framework. So either nothing is impossible, or your explanation quietly reintroduces the thing nothing was supposed to remove. That's the no-escape corner. Not a proof, a structural trap. And it suggests why the question is so fertile. It forces you to separate empty from absent, and explanation from origin, and story from structure. So let's land the meaning without pretending to solve it. We have learned something precise. We have learned that the simplest human picture, nothing is default, something is addition, is not supported by the way physics treats emptiness. The vacuum is active, the universe is mostly unseen. Our best frameworks disagree violently about what the baseline should mean in gravity, and the idea of before the beginning may be a misuse of time language. So when you ask why anything exists, you are not asking for one missing fact. You are asking what reality is at the deepest layer. Is reality contingent, one choice among many? Is reality necessary, the only consistent structure possible? Is nothing coherent or self-erasing? Science can prune the fake answers. It can show you where intuition breaks. It can force your stories to match measurements. But when you demand a final reason for the framework itself, you reach the edge of what we currently know. And now we can say the final reframe cleanly. Existence isn't just stuff in space. It's the structure of consistency that makes any space, any law, and any event possible. Why does that matter? Because it changes what you think you're doing when you ask questions. You're not a spectator watching a universal timeline unfold. You are a physical system inside a universe that permits stable systems, stable memories, and stable explanations. A thinking organism made of atoms obeying laws it did not invent. And the deepest question you can ask is not what happened first. It's why is there a lawful arena in which first even makes sense? Not comfort, truth, no applause, no closure. And the fact we can even see the boundary, can even point to the place where understanding breaks, that's the miracle. And that raises the next question. If laws are the structure of existence, are they inevitable or selected because coherence is the price of reality?